In general, if you have a metal cation, it can react with nucleophiles, form coordinate covalent bond with nucleophile to form a complex ion. So for example, if you have silver ions in water, it can form covalent bonds with two ammonia molecules to give you this complex ion right here. This is called the silver diamine complex. Okay, NH3 is an example of what's called a nucleophile. Anything that has a lone pair that it can share with your metal cation would be a nucleophile. It will be seeking a positively charged center, so it's seeking a nucleus. Okay, so that's why it's called a nucleophile. So in this particular reaction, we say your ammonia is an electron pair donor. That's what we would call a base in the Lewis definition of acids and bases. Okay, so this is a more generic definition of acids and bases. The lone pair on the nitrogen is shared with the silver. There's actually a covalent bond. Okay, and we call that bond a coordinate covalent bond. So your silver ion actually forms a covalent bond with this nitrogen in your ammonia. Okay, so the lone pair of the nitrogen is actually shared with the silver. Okay, so that bond is called a coordinate covalent bond. Your silver ion, metal cation here, is an example of what's called an electrophile, an electron lover. Okay, so that's the electron pair acceptor. That's defined as the Lewis acid. Now, the formation constant would just be equal to, okay, the KEQ for this reaction, where you're forming the complex ion from the metal cation and the nucleophile. So right here, if you look at this reaction, okay, the KEQ for this reaction is called the KF of the complex ion that you made. Okay, so KF, F for formation, so K sub F is the formation constant of this complex ion, would just be this concentration of product divided by concentration of silver times, in the denominator you have concentration of NH3, and this is squared because there's a coefficient of 2 right there. Okay, so that's your expression for the formation constant of a complex ion. So CuCl4 -2 is a complex ion formed from copper ions and chloride ions. What is the reaction is KEQ is called the KF of CuCl4 -2. What kind of reaction are we talking about here? We're forming one CuCl4 with a -2 charge from what? From the cation, which is copper, and chloride ions, your nucleophiles, right? And how many chlorides do we need to balance this? We need 4 chlorides, so 4. Okay? So that is your reaction for the formation of CuCl4 -2. The KEQ for that is called the KF, or the formation constant of the tetrachlorocopper ion. Okay? So what is the expression for KF of CuCl4 -2? Is it A, B, C, or D? What was our reaction again? Copper plus 4Cl minus gives you CuCl4 2 minus. This is aqueous solution, aqueous solution, and aqueous solution. Okay, correct answer B. Products over reactants. Yep.